All right, we're going to talk about how we can find linear functions from tables and from graphs. Okay, and you may have seen this before, but this is going to be a really good review, and we'll hopefully cover maybe some details that you haven't seen before. First question in the warm-up says, what is the formula for the slope between 2 points? My gosh, I hope everybody's got that one. If we're talking about 2 points, we usually do y2 minus y1 over x2 minus x1. But remember, we could replace these with the function values, so this could be f of x2 minus f of x1 on the top there, because those are the same as the y values. What is slope-intercept form? Gosh, we all need to know that one. Y equals mx plus b, where that m is the slope and b is the y-intercept. And it says put x and y in the appropriate blanks if we're going to put them like that. So remember, f of x is the same as y. And then the last thing, I'm hoping everybody knows what this one is, because this is a really important thing to remember. It's good to have a nice quick definition for what slope is. Slope is a fraction. It's always best to think of slope as a fraction in one way or the other. And it's a fraction that represents how steep the line is and in which direction it slants. So does it slant up or does it slant down from left to right? Now, for the most part, this section is again going to be a review of ideas, things that you've already seen. Okay, but finding equations of lines is a skill that you are going to use all the time in tons of different classes, so we need to be really good at it. And as a reminder, here is a very key idea. In order to write the equation of a line, we always need two things. We need a point, got to have a point, and we need the slope. Now, I've got a little asterisk by this because sometimes, they'll always give us a point, and sometimes they'll give us a slope, but other times they'll give us enough information that we can figure out what the slope is. But it always comes down to these two things. We've got to have a point and we've got to have a slope. Now, instead of using the format that we're familiar with, y equals mx plus b, we're using functions. So we're going to try and use function notation in order to write this. And I'll give you a couple different ways to work this. But slope-intercept form would basically come down to this. We're replacing the y with f of x, and this would be m times x plus b. So instead of y equals mx plus b, we're going to have f of x equals mx plus b. So on this first one, it says, write a linear function that goes through negative 7 comma 2. So notice there's a point, and has a rate of change of 3/7. Now notice that they said rate of change, but when somebody says rate, you should automatically be thinking slope. Now, we can find the y-intercept by remembering a really easy fact, and that is if a point is on the graph, as they mentioned that this one is on the graph, then it's got to work in the equation. Okay, so that's going to come up in just a second. And if it helps, what we can do is we can use it, kind of do it the old school way and use y equals mx plus b. And then at the end, we're going to change to function notation. We'll just replace the y with an f of x. So here's what we're going to do. We're going to write down y equals mx plus b. And they told us that the rate of change of the slope was 3/7. So we've got y equals 3/7 x plus b. What we don't know is we don't know the y-intercept, and this is where this comes in handy. We do know that this point right here is on that line, so this xy pair had better make that true. So that means we're going to plug in a negative 7 wherever there's an x and put a 2 wherever there's a y. So we're going to put a 2 where there's a y. This is 3/7 times negative 7 plus b. We'll do a little bit of cross-canceling here. The 7's going to cancel with the 7. That does still leave the negative there, so this is going to be 2 equals, this is negative 3 plus b. We move this over to the other side, and we end up with b equals 5. Now, sometimes I like to put a dotted line around this right here because we're almost done. We're like halfway there. We know what the slope is, we just don't know what the y-intercept is. So we're going to come back here, we're going to put it in there, and I'm going to write 3/7 x plus 5. And then again, instead of writing a y right here, I'm going to go ahead and write f of x because we are using function notation here. So this is what I'm going to write. Okay. Now you might recall that one way that we can check and make sure that we got our answer right is we can actually plot the point. So I'm going to draw this graph right here. So this one's going to cross at 5, and maybe we'll zoom in on this one just a little bit so we can see. Okay. So this one's going to cross at 5, and the slope is 3/7. So that is rise 3. And we would run 7. So that's going to be right there. Okay, and that's as much as we can fit on that side. And then we've got down 3 and back 7. So that's going to be right there. And then we can connect these, nice smooth lines, straight as we can, put arrows on the end and stuff like that. And then we're going to come through here and we're going to say, well, look, is this point, is that on that graph? If it is, if it's on the graph of that function, then we got this right. So if we go to -7 and up 2, that's the point right there. So -7, 2, we definitely got that one right. We're in good shape there. Okay, so that's one way to check if you've got a graph. Otherwise, you can just be really careful with this. So the next thing we want to do is we want to write a linear function that goes through -4, 8 and then 2, 5. Now, in order to do that, we've got 2 points, but we don't have a slope. So here's the first thing we want to do. We want to find the slope. So we're going to do y2 minus y1, and I kind of like doing this. I kind of like drawing those lines right there. So I'm going to do 5 minus 8. And one thing that people typically do is they'll do the x's first, and they'll put them in a weird order or something like that. We always want to do the y's first, so we're going to do y2 minus y1, and then this is going to be over x2 minus x1. So that's going to be 2 minus, and remember, the minus is part of the formula. This is another common mistake. And then they say, oh, well, that was already negative, so they don't put those two back to back. So here's what we get. We get -3 on the top, and we get this turns into a plus, so this would be 6. So this is -1/2. So here's what this means. We've got y equals -1/2 x plus b. We're a little more than halfway there, and now we just need to plug one of these points in. So the cool thing about this is, rather than just having one point that we get to choose to plug in, we've got 2. And usually we just want to pick the easiest one. So I'm going to go ahead and plug this one in. So I'm going to plug in 2, 5. So that means this is the x and this is the y. So we're going to do 5 equals -1/2, and the x is a 2. And we kind of made this work out really nicely. Those are going to cancel. So this is a 5 equals -1 plus b. Move that to the other side. So that's going to be 6 equals b. So we move that to the other side by adding. So we've got this right here. And again, sometimes I'll circle this because we are almost done. That way I know what to go back and find. So here's what we'll write down. We're going to write down f of x is equal to the -1/2 x, and then the y-intercept is 6. So there we are right there. Now, I am going to mention one quick thing. Some of you may be familiar with something called point-slope form. I find point-slope form much easier. Some people really like it, some people don't. So here's what we do. Point-slope form works like this. It's y minus y1 equals m times x minus x1. And this is what's nice about this. So I'm going to go ahead and write this down as x1, y1, and actually I'm going to change colors so we can show the work a little more clearly. This is, whoops, let me get that green going. Here we go. So this is x1, y1. And we already found the slope, so we do still have to find the slope there. But we're going to write down y minus y1. Now again, the minus is part of the formula, so we're going to write down y1 is 8. And then the slope is -1/2. We found that right here, so -1/2. And then x minus x1. So x minus, and then x1 is -4. Now, if you've never seen this before or don't like it, that's totally okay. All I'm going to do is I'm just going to do a little bit of distributing and simplifying. So this is going to be -1/2 x. And then this is going to be a +4 because remember, it was a minus 4. So when we multiply the -1/2 times the +4, we get a negative. And then half of 4 is 2. Now, the only thing left to do on this one is to just add 8. So I'm going to add 8 and watch what happens. We get y equals, this would be -1/2, and then -2 plus 8 is +6, and you'll notice that that right there is the same thing as this right here. Now you still have to do this work, but this blue work right here is comparable to this work right here. So again, it's about 6s either way, half a dozen one way, 6 the other. Not a big deal, but if you do like point-slope form, and I highly recommend that you practice that a little bit, that can be kind of nice. Okay, let's take a look at the next one, because on this one, sometimes we get our points in tables, and then other times we get them as in graphs, rather than them just flat out saying, okay, here's a point, there's a slope, here's a point, you need to find the slope or the rate and stuff like that. So on this one it says write the linear function using the information provided. So I'm going to slide over here. And down below here it says it doesn't matter which points we pick. So they've told us that this is a linear function. We're going to get a linear function out of this. So it doesn't matter which one of these ordered pairs we pick. We can pick the first one, the second one, the third one, or the fourth one. We just want to pick ones that are convenient, and normally the ones with positives or smaller numbers, those are usually better. So here's what we're going to do. We're going to do the y2 minus the y1 over x2 minus x1. And I'm going to choose these guys right, whoops, I'm going to choose these guys right here. Okay, we're going to do those two. And the reason we're going to do those two is because these are positive numbers. It's only got one negative in there. So here's what we're going to do. We're going to do y2 minus y1. So these are the y's, or the function values, if you will. 5 minus, make sure you write the minus before you go grab that point. So this is a minus 1. And then this is going to be x2 minus x1. So notice if I do it in this order, I've got to do that one in that order. Please don't mess those up. So this would be 6 minus a 2. So we get, let's see, we get this is going to be a plus, so that's a 6 on the top, a 4 on the bottom, so we get 3 halves. So we would have y equals 3 halves x plus b. Again, we're just about done. All we need to do is plug one in. It doesn't matter which one we plug in. This one has all positives, but these are a little bit smaller. I'm going to go ahead and stick with the positives and just see how this works out. So this is the y value. So this would be 5 equals 3 halves times 6 plus b. Again, this is another one that works out pretty nicely because the 2 would cancel with this. 2 goes in here once, 2 goes in there 3 times. So we're going to have 5 equals 9 plus b, and then we're going to subtract the 9 from both sides, so we get negative 4 equals b. So I'm going to go ahead and put a dotted circle around that, and then I'm going to take the 2 dotted things and we're going to put those together in function notation. So again, this would be f of x equals, this is going to be 3 halves x, and then minus 4. And that should work right there. Now we could always take a couple of these points and plug them in and see if they actually work. Like plug in a negative 4 and see if we get an f of negative 4 is negative 10. Okay, so let's turn our attention to this one right next door. Again, we've got to come up with a linear function, and this looks like we have far less information, but if you look really closely, gosh, we've got a ton of information right here. So again, that's the y-intercept right there. So we automatically know a particular point, a very special point on this one. The y-intercept is 1. And then all we've got to do is we've got to find a convenient point here. So let's take a look. That's a nice convenient point because it crosses on where two of these lines cross on this grid. That's not. How about right there? Okay, so this would be down 2 and over 3, like this, down 2 and over 3. Let's just double check and make sure that that looks good. So if I followed that pattern, does it match up every single time? Sure looks like it does. There's our little stair step pattern. We can kind of see that those are equally spaced. So we get negative 2/3. So this would be f of x is equal to negative 2/3, because that's the slope, times x, and then plus 1. Circle that and we're all set to go. Okay, the last little bit that we want to talk about is example 4 and 5, both closely related. So on example 4, it just says, hey, would you draw a horizontal line and state what its slope is? And on B, it says, draw a vertical line and state what its slope is. So I'm going to give you just a second to do that. Go ahead and draw what you think a horizontal line looks like here and a vertical line right here, and then state what their slope is. So I'm hoping you got that right there. Horizontal is perfectly flat, like the horizon, and the slope of that would be 0. There is a number that represents how steep this is. It's 0. It's not steep at all. This, on the other hand, is so steep, there is no number that represents how steep that is. So there are a couple different ways we can describe that. We can say no slope on this one, or we can say that the slope is undefined. And really quickly, let's just run through why. If we were to go from this point to this point, we would run, but we wouldn't have a rise. So we would have a number on the bottom, and the rise would be 0. Well, if you take 0 and divide it by a number, you're going to get 0. On the other hand, if we go from here to here, we're going to rise, so we're going to have a number up here, but no run. We didn't go right or left at all. And that is undefined. We can't divide by 0, so we don't get an answer for that. So this is perfectly flat. This is so steep, there's kind of the opposite. There's no number that represents how steep it is. So x equals a number, that's this one right here, is a vertical line. So if you see x equals a number, it's a vertical line, and y equals a number is a horizontal line. So horizontal, y equals a number, vertical, x equals a number. So make sure that you have those straight. And then let's take a quick look down here, label each equation as horizontal or vertical. Again, if it's y equals a number, that's going to be horizontal. If it's x equals a number, that's going to be vertical. X equals a number, even if it's an ugly number like that, that's going to be vertical. Okay, and f of x equals -2. Well, stop and think about this. Remember, f of x is the same as y. So this is like saying y equals -2. So that's going to be a perfectly flat line like this one right here. That is going to be horizontal. And there's a little thought experiment right here. Should a vertical line be written using f of x? So could we write a line that's straight up and down as f of x? So the answer to that is no, and the reason is if it's vertical, if it's straight up and down, it's not even a function, so we probably shouldn't use function notation. So go ahead and do the self-assessment right here, and then we're going to take a look at number 12 from the assignment. So we've got the practice assignment up for 4.4. The instructions on this say write a linear function for each problem and write at least 6 of them using function notation. So you don't have to use function notation on every single one of them. You don't have to write f of x, but you need to do it on at least 6 of them, kind of like we're showing in the assignment. But take a look at number 12. Take a look at what that is. Vertical line, so we can't use function notation on that. So remember, vertical line, is that an x equals or a y equals? Go ahead and write that down, and you've already got one done on the assignment. Good luck.